Hello. This video is about L'Hopital's rule, which is a very particular method of evaluating certain very particular kinds of limits. Okay, let's look at some examples. We had this one earlier. We're taking the limit as x approaches 1 of root x over x squared minus 1. It's 0 over 0, so L'Hopital applies. We get limit as x goes to 1 of the derivative of root x minus 1 over derivative of x squared minus 1. And that is equal to, well, here is the derivative of root x minus 1. It's 1 over 2 root x. And here is the derivative of x squared minus 1. It's just 2x. Now we let x go to 1. The numerator goes to 1/2. The denominator goes to 2. So altogether, that limit is 1/4. So L'Hopital's rule says that since the limit of the quotient of derivatives is 1/4, the limit of the quotient of the functions is also 1/4, and that's what we get for our answer. Let's do one more example that's a 0 over 0 form. We saw this one before. We take derivative of numerator. Derivative of sine is cos. Derivative of cos is minus sine. So we have minus sine, which is plus sine. Derivative of x minus pi over 4 is just 1. And so now when we take the limit as x approaches pi over 4, of cos x plus sine x, we'll just get cos pi over 4 plus sine pi over 4. Each of those is root 2 over 2, so when you add them together you just get root 2. So that limit is equal to the square root of 2. That is how L'Hopital's rule works for infinity, for 0 over 0. Example 3 is infinity over infinity, and we're letting x go to infinity. Again, L'Hopital's rule applies because the numerator goes to infinity and the denominator goes to infinity. We replace them each with its derivative, and derivative of log x is 1 over x. Derivative of e to the x is e to the x. Now when we let x go to infinity, the numerator goes to 0. 1 over x goes to 0 as x goes to infinity, and e to the x goes to infinity. So we're going to 0 over infinity. Well, that is just 0. And the fourth example, we're letting x go to 1, log x over x minus 1. Log x goes to 0 as x goes to 1, because the log of 1 is 0, and x minus 1 goes to 0. So that is 0 over 0. We take derivatives. We get limit as x goes to 1 of 1 over x and 1, and so the limit is 1. So that is L'Hopital's rule and how it works. And we have to check that we can apply it, and then it's straightforward to apply it. The next thing to talk about are these two situations. These are errors. There are things wrong with these two calculations. The question is, what is wrong? We let x go to 3. We have x minus 3 over x squared minus 3. So we take derivative of numerator. We get 1. Take derivative of denominator. We get 2x. Let x go to 3. And that means the limit of 1 over 2x as x goes to 3 is just 1/6. So the limit of x minus 3 over x squared minus 3 as x goes to 3 is 1/6. That's wrong. And what is it that's wrong here? Well, back at the beginning, we do not have a 0 over 0 form. The numerator goes to 0, but the denominator goes to 9 minus 3, 3 squared minus 3. So the limit of the denominator is 6. So the limit is 0 for the quotient, and L'Hopital's rule does not apply. Okay, here's our second error. Let x go to 0, 1 minus cos x over x plus x squared. If we let x go to 0, the denominator will go to 0. The cosine of 0 is 1, so 1 minus cos x goes to 0. So I do have a 0 over 0 form. Well, that's good. I can use L'Hopital now. So I take derivative of numerator, and I just get sine x. Minus cos x has derivative sine x. The derivative of the denominator is 1 plus 2x. And now we apply L'Hopital again, and we get derivative of sine is cos. Derivative of the denominator, 1 plus 2x, is 2. And so as x goes to 0, we get 1 over 2. Wrong. We were not really allowed to do that second L'Hopital, because as x goes to 0, the numerator goes to 0, but the denominator goes to 1. So this is what's wrong. You cannot use L'Hopital here. So you will get wrong results if you apply L'Hopital to forms that are not indeterminate, and it's important for you to be careful about that.